Dear ladies and gentlemen, welcome to our presentation. My name is Nikolai Gotsev and I'm responsible for the marketing and sales at IPS. Today I would like to meet you with one of our top innovations, EXERON, the system. We believe that this technology and system concept is a milestone in the area of hybrid energy storage. Let me first briefly present our company, we're IPS or International Power Supply. IPS is a private Bulgarian family company with 25 years of history and experience. Our main activity is research, design, development and manufacture of power supply systems. We are one of the few companies worldwide offering in its portfolio a full range of power systems in the low voltage area, from 12 up to 400 volts. Our products find application in all industry sectors. Next to the usual certifications, we have covered the NATO military standard for quality, AQAP 2110, which guarantees very high-class production. As a consequence, we at IPS are proud to be a long-year and well-accepted supplier of NATO in the United Nations. We believe that we deliver exceptional quality and creativity, and this fact has to be an evidence for that. Our goal is to become an international company. We are now represented in Europe, Africa and Asia. Our headquarters, our home, is located in Sofia, which is the capital city of Bulgaria. This is where our R&D and manufacturing facilities are. We have customers in 39 countries. We are a small, high-tech company with huge know-how, and our international presence is rapidly growing in the last years, and we are now looking for a strong partner. We believe we have developed something exceptional. Currently, we manufacture 33 different products. As we mentioned it earlier, our power systems cover the range from 12 volts up to 400 volts, which makes them suitable for applications in all industry sectors. That's, for example, turnkey telecom power systems, outdoor systems for military applications, DC systems for railway and energy substations, inverter systems for power plants, etc. Last but not least, we have a portfolio of hybrid storage system using renewable energy. Let me take a deeper look in our company concept for all of our products. The basic principles that we always implement during the design and development of new products are modularity, as you can see it from the sample picture, scalability, exceptional reliability, efficiency, and of course, latest level of proven technology. I would like to underline again, not just the modular structure, but the fail-safe modular structure, which we will explore deeply in the next slides. Now, let me take a look in some typical applications and real implementations. We start with telecom outdoor solutions. The area of telecommunications is requiring more and more solutions that are space and energy saving, offer more functions and features, and for some regions are energy independent, working for minimum OPEX costs. We are in good position to offer all kinds of turnkey outdoor power systems. They are for wall or pole mounting, as well as freestanding, waterproof with free cooling, or with air conditioning providing the highest level of security and well-being for power and telecom equipment and battery. The metal enclosures, power system, and distribution is all designed and manufactured by us. Another group of products, the indoor DC solutions. Those kinds of systems are called rectifiers and provide power to DC-driven equipment as well as battery charging. You are seeing again the modular structure. Typical system voltage in this case is 48 volts DC, but not only. Next product group, reserve power for energy substations. They are typically operating at 220 volts and have to cover a lot of special requirements. Another group, railway power. Operating normally at 110 or 60 volts DC, the systems are used to supply automatic signaling or telecom equipment. You will see one case of the special production. covering highest electronic requirements for reliability, safety, and non-stop operation in the harshest conditions to power systems for military and defense applications, are the masterpiece in our portfolio. Without any parameter change or reduction, they have to resist temperatures from -40 up to +80 degrees centigrade, water, acid and dusty environment, high electromagnetic disturbances, seismic shock waves, etc. Now, we are ready to go further to the next interesting area, the renewables and the intelligent hybrid power. For the last years, we developed a concept for a hybrid off-grid system with energy storage that after a lot of improvements and modifications now seem to be extremely future promising. From the shown installation, it can be clearly identified a hybrid system, the PV field, the storage strings, as well as the automated emergency backup power with the diesel generator. On the next slide, we can see more off-grid systems. In this case, for outdoor use with energy storage. Here, more hybrid power. A school swimming pool is powered from PV off-grid system with storage. Supplied are pumps, heaters, air conditioning. And now, you may have noticed that we came to the focus point of this presentation. Relax and take a look in the quotation from the great Henry Ford. If I had asked people what they wanted, they would have said faster horses. I will let each one of you interpret this amazing thought by yourself. But now, I want to ask you the following. Please forget all you know about hybrid storage systems, open your mind, and enjoy. Now, we will speak about EXERON. We will not speak about the product, and you will not think about the product. We will speak about the system, and please, you also think about the system. EXERON is a multi-talent system that can use, combine, manage, store, supply energy, and takes decisions how much, when, and how to do it. And the input, we can have PV, wind, grid, diesel generator, batteries for storage, and different kinds of loads like residential, industrial, telecom, AC and DC, 1 or 3 phase, 110 or 220 volts, 50 or 60 Hz. We don't think about the product anymore. We think about a system. But what is actually the definition of a system? Wikipedia says the following. A system is a set of interacting or interdependent components forming an integrated whole or a set of elements, often called components, and relationships which are different from relationships of set or its elements to other elements or sets. A system has a structure. It contains parts that are directly or indirectly related to each other. A system has a behavior. A system has interconnectivity. A system's structure and behavior may be decomposed via subsystems and subprocessors to elementary parts and process steps. On the market until now, you can find many units, many products, many good units, many very good products, but now we have a system. We have a network infrastructure, we have objects in the network, we have behavior between the objects, power sharing and risk sharing between the objects, we have intellect. Let me go in details. Imagine objects in a network communicating to each other. The number of objects is from 1 to n. In this case, the objects are a group of PV and PPT charge controllers. This is a system. Now, imagine other objects in a network communicating to each other. Number of objects is from 1 to n. In this case, the objects are a group of grid or diesel generator charge controllers. This is a system. Other group of objects in a network communicating to each other. Number of objects is from 1 to n. Objects are inverter modules. This is a system. Next group of objects. Battery strings. This is a system. Now, let me please think about subsystems. Each of the system now is a subsystem. Voila! This is the EXERON system concept consisting from many subsystems from 1 to n. We know that it is a system, but it's not just a system, it's a beast, because for each EXERON subsystem from 1 to n can reach 16,300. Yes, 16,300. There's no mistake. And now, just a beast example. We take the subsystem of inverter modules and consider one inverter with maximum output power of 4 kilowatts. Multiplied by 16,300, it makes 65 megawatts system output power. It's a beast, isn't it? On the next slide, the main system objects are presented. You see the PV MPPT charge controller for connecting of up to 2 kilowatt peak PV string, independent of type, mono, polycrystalline or thin film module. Below is the grid diesel generator charge controller, the so-called rectifier. Its maximum power is 2 kilowatts. Next to them is the inverter module with 4 kilowatt maximum output pure sine wave power, and the MCU, the main control unit and the heart of the system, which controls everything, takes decisions and communicates with the world. All of them communicate with each other, exchange information and share load. Yes, they share load. About the physics, it's extremely important if we think about maintenance and after sale period. The dimensions are very small. The inverter is like a shoebox. The charge controllers, 4 of them could pass in one shoebox. Each of them is less than 2 kilograms. All modules are plug and play. You don't need any tools or special keys, nothing. During module exchange, you don't have to stop or shut down the system. No need, because the modules are hot swappable. Nice, isn't it? So we talked about dimensions, weight, size, communication, main control unit to be heart of the system. We mentioned also load sharing. Maybe you just begin to think about what could happen in case of failure. The fact? Yes, you're right. This is electronics and failures could happen. The more important thing is to be prepared. Let me take a look in one of these situations. We at IPS are always thinking and prepared for even the worst case. Imagine a working system with 5 modules, for example, grid charge controllers. Let me put at the input 10 units of power. Then what happens is the balanced load sharing between the modules. Each module is loaded with equal amount of power, let we say 20% for each. We assume there is a failure and then one of the modules is down, not working. In only 2 milliseconds time, the system shares the load between the working modules. We now have a new power balance. You see the new power load sharing of the modules, 25%, because they take the load from the failed module and share his load between themselves. The biggest advantage in this case, we have the same amount of power at the output, exactly because this load, and said in other words, risk sharing. This is called redundancy of the system. It is a fault-tolerant behavior. It is the same for the inverter modules. But now, please pay attention. What happens in case of MCU failure? Nothing. Because each other module is equipped with microprocessor, and in case of MCU failure, and because of the network structure of the system, the next free module in the communication channel will take the control of the whole system. The main principle implemented in the system concept. Whatever happen, a full system stop is impossible. Let me finally talk about the advantages. First of all, the modularity. Practically the system by itself divides entity into many small parts, which determines many advantages, because these many small parts share also the risk of the whole entity. Because of that, we speak about redundancy. We saw it already with the last example case. EXERON is time and money saving. The MTTR, mean time to repair, is practically 0. This is the time in which a module is not working. All you need to do, in this case, is to exchange the failed module with a new one, just by pulling it out, and without any tools, and the whole procedure without even stopping or shutting down the system. The new module is plugged in under voltage. After that, it synchronizes with other modules and shares immediately the load with them. Next point, power planning. You're free and flexible to plan even if you don't know exactly how much power you will need tomorrow or in some months or years. Imagine you want to start with 10 kilowatts, but maybe you have to start with 15 or even later increase it to 40. Do not worry and do not invest more than needed just for the case to have it, but without the real need to use it. The modularity gives you the perfect opportunity and freedom to plan a reserve power. You just buy the initially needed 10 kilowatts and infrastructure of the system to be capable for more modules. Practically, you will have your 10 kilowatt power capacity with modules, in addition the free space, free slots for modules in the future. When the time comes and you need more power, you just have to buy some new modules. And as we saw, one controller has 2 kilowatts. You can add always new modules in 2 kilowatt small power steps. The flexibility of the system gives you even more freedom. Thanks to the small modules used for input and output, they can easily be in balance depending on the need of the project. If you want for 1-2 hours sunshine during the day to charge the batteries fully, and in the evening and during the night to power some equipment, then you can take more input charge controllers, for example 10 kilowatts, but only 2 kilowatt inverter for the output. Otherwise, if you want to charge all day long the battery and then in the evening to supply some power for equipment for 1 or 2 hours, then you can design your EXERON system with 2 kilowatt modules at the input and 8 kilowatt modules at the output. The choice is actually fully yours. This is the whole structure. It looks complicated, but actually it's very simple. Now, let me materialize all the good things that we said about EXERON and see how it looks. This one is an example configuration of EXERON MX. Here is the section for the PV and PPT controllers, in this case 6. We have also 6 AC chargers. Here is the inverter section with 3 inverter modules in this case. MCU, the main control unit, and in the upper part is the PDU, power distribution unit, where all input-output connections, switches and protections are located. So there is no need of buying any kind of additional distribution equipment like power boards, fuses or any circuit breakers. Here, just to see 3 different scaled configurations of the modular system. This was the Beast, also known as EXERON, a flexible and modular system from 2 kilowatts up to 65 megawatts, scalable in power steps of 2 kilowatts. Some typical applications for EXERON are diesel generator replacement or significant optimization by decreasing the OPEX costs. We developed a case for up to 98% OPEX cost savings. Water supply or power delivery for remote places without any infrastructure is another good application for EXERON, but not only. Many others are appropriate. We at IPS believe that EXERON is a part of the future. Still now. Invest in IPS EXERON and become our partner. Do not assemble a system from different kinds of components. You already have a solution, a system from only one manufacturer, which is fully integrated and unified. Imagination is more important than knowledge. Knowledge is limited. Imagination encircles the world. We realized our imagination, and the result is EXERON.